Thomas Cormier and his team recreated the conditions of the universe right after the Big Bang, approximately 13.8 billion years ago.
Now, at this facility, what we do is we collide elementary particles. My specialty is colliding whole nuclei, whole lead nuclei, circulating around this accelerator in opposite directions at really unprecedented energies, are brought into collisions as a means to produce tiny samples of ordinary matter heated to trillions of degrees centigrade and compressed to hundreds of times the density of normal nuclei to essentially turn back the clock. This tiny sample of matter is similar to, it turns out, what the matter that made up the universe was like when the universe was only a few microseconds old. So it's basically using that facility and those special ions gives us a window into the nature of the matter that filled the universe when it was only a few microseconds old. What we do is we take a sample of matter the size of a lead nucleus and heat it, as I said, to trillions and trillions of degrees until the matter melts into a soup, which is very much like the early universe in the first few microseconds of its existence. And then our detectors help us study the properties of that matter and observe it as it expands and cools and turns back into ordinary matter. So we can trace it from the instant of the collision, where the temperature goes from essentially zero all the way up to trillions and trillions of degrees in the collision, and then watch the collision come apart in our detectors. As the matter cools back down, it can watch the transitions that it goes through, the same transitions that the early universe went through, where the early constituents of the universe was this soup of quarks and gluons at very, very high temperature, which expanded. The universe expanded through its first moments of existence, and as it expanded, it cooled in the same way that our little mini bangs expand and cool when we perform these collisions at the Large Hadron Collider. So we can study how ordinary matter reappears from the start with these collisions that create the matter of the early universe, and then study it as it reemerges as ordinary matter, and what kind of matter is made. We make the protons and neutrons, for instance, that make up everything around us today, appear in our collisions. So we start with matter heated to trillions of degrees where there are no protons and neutrons. There are only quarks and gluons, and then we watch it cool and expand, and we watch the protons and neutrons emerge again from this hot soup, just the way they did from the early universe. So it is really sort of an experimental probing of how the universe behaved in that first few microseconds, which we can then compare with the theories of the early universe.